Hey again, geometry students, we're doing a good job so far getting through our review packet. So let's go ahead and get a few more questions done today, then we'll finish up our questions tomorrow. We're picking up today at question 24, and this is where we talked about our vectors and how to correctly decompose a vector. The same information is used on questions 24 and 25. You can read there, it says vector v has a magnitude that was its length of 100, and it makes a 55-degree angle with the horizontal. The first thing we're answering there on question 24 says to find the horizontal component. Now, if it helps you on these questions, if you want to draw a picture out, you're more than welcome to. I am not going to have a picture drawn there for you, so let me see if I can do that real quickly. It's not going to be the best picture because I'm freehanding it here. We had our magnitude, which was the length here, so I'm going to put my 100, and then the angle was right here. That's where I'm going to put my 55 degrees. Well, the two pieces that we are looking for are the horizontal and the vertical. What direction is horizontal? It's going left and right. And what direction was vertical? It was going up and down. So let's start with the horizontal. Well, from that angle of 55, because I always have to start from the angle when I'm looking for a piece in a right triangle. So I can put my right angle in here as well. From the 55, the horizontal piece is the adjacent piece, and this magnitude is the hypotenuse. Well, what ratio is adjacent and hypotenuse? It is the cosine. Remember, to find the horizontal component, we always use cosine. So I said cosine of my angle, 55, and there's just the notation for the horizontal. It was vector v, and then I got a little x, because x is in the horizontal direction, and there's my hypotenuse of 100. Well, to get the vector x component by itself, we need to get rid of the divided by 100, so I'm going to multiply by 100. Remember, don't do 55 times 100, it's 100 times the cosine of 55. When I typed it on my calculator, I found out that the horizontal component was 57.36. Now, the next question is the vertical component, so let's look at our picture here, because it won't be on the next slide here. The vertical component is going up and down. From the angle, the vertical component is the opposite side, and the magnitude is still the hypotenuse. What ratio was opposite and hypotenuse? It is the sine ratio. So to find the vertical component, if you remember, we always use the sine ratio. So I said sine 55 is equal to, there's my vertical, so vector v with the letter y, because y is what's going up and down on the Cartesian plane, over the hypotenuse of 100. Just like we did on the horizontal part, to get rid of dividing by 100, we multiply by 100. So my vertical component, 100 times the sine of 55, gave me 81.92 for my vertical component. So horizontal is always cosine, vertical is always sine in our question. Moving on to question 26 and 27. These were the trig identities that we talked about. I believe it was also out of lesson 91. You can see those two trig identities are on your review packet, which means they're going to show up on your final as well. So if it says find sine theta if cosine theta is equal to 0.7. So I got to decide which one of those two identities that's showing up on my packet would I need to use. Well, this question is talking about sine and cosine. Which one of those two ratios or identities only uses sine and cosine? It's the first one, where I have sine squared theta plus cosine squared theta is equal to 1. I know what the cosine is, so we can replace that here in just a second. That would leave us with the sine ratio, which we are attempting to find. So let's go ahead and try to do that. We are told that cosine is equal to 0.7. Now notice the formula here, or the identity, says cosine squared. We just have cosine, so as I replace that 0.7 in, I still have the square that is on that. So we have sine squared theta plus 0.7 squared is equal to 1. Let's do that exponent first. So I did 0.7 squared, and that gave me 0.49. So sine squared theta plus 0.49 is equal to 1. Well, the question says to find sine, which means I need to get sine all by itself. You're just solving a basic algebra problem here. What do I need to do to get sine by itself? Well, step number 1 is to subtract over that 0.49. 1 minus 0.49 was 0.51. One more step to get sine by itself. The sine has a square on it. What's the opposite of a square? It's a square root. So on my calculator, I did the square root of 0.51, and I found out that sine theta was equal to 0.71 for my final solution. Let's follow question 27 with what that problem wants us to do. It says to express sine theta using only cosine. Well, what does that mean? The question is asking you to write sine theta, so it's going to say sine theta equals, and what you have on the right side of the question involves the cosine ratio. Well, again, we got to think. Which one of those two identities that's given to you in the instructions involves the sine and the cosine ratio? Once again, is the first one. So sine squared theta plus cosine squared theta is equal to 1. Well, again, my job is to express as to write sine equals something. So I need to attempt to get sine by itself, just like I did on the last question where it had numbers. Well, to get sine by itself, the first step would be to get rid of the cosine squared. How do I get rid of the cosine squared? I would subtract it to the right-hand side. So I have sine squared theta equals 1 minus cosine squared theta. I can't put those two together because they're not like terms. One more step to get the sine all by itself. The sine currently has a square on it, so how do I get rid of a square? I'm going to square root. So sine theta is equal to the square root of 1 minus cosine squared theta. Remember, I cannot square root that because of that minus sign, so don't try to cancel out the exponent there. That's your final answer. You have written sine using cosine. On the left side, it says sine theta equals something, and the right side of your question involves the cosine, which is what the instructions asked you to do. One more question for today, number 28. Number 28 says the vertices, which are the corners of my quadrilateral ABCD, are located at A, 1, 4, B, 5, 7, C is 6, 5, and D is 2, 2. Our question, is this quadrilateral a parallelogram? Well, it'd be helpful to know, what does it mean it's a parallelogram? A parallelogram has opposite sides that are parallel. The top and bottom are parallel to each other, and the left and right are parallel to each other. Well, how do I know if sides are parallel to each other? They have the same slope. And you see there under 28, I have the formula there for you for the slope of a line. It says y2 minus y1 over x2 minus x1, so that would appear on your final as well. So here's the picture that I have drawn out. I put the ordered pairs in my picture. You can do the same thing on your picture if you wanted to. I just put the letters on your picture. So I'm going to begin on that slanted piece that's on the top. I'm going to find the slope going from A to B. So as I filled in my formula, I went from right to left with my numbers. So the y that I have here is 7 minus the y that I have down here is 4. In the denominator, the x, I got to go in the same order from this direction over to the left. The x that I have is 5 minus this x, which is 1. So let's subtract. 7 minus 4 is 3, and 5 minus 1 is 4. I have 3 over 4, and that fraction does not reduce, so I know the slope going from A to B. Well, that means this slope going from A to B better be the same slope going from D to C, because those are the pieces that are across from each other. The opposite sides were supposed to have the same slope. So let's check the slope going from D to C next. I went in the same order. I started at the right and I headed to the left as I filled in my formula. So I have my y, which is 5, minus my y, which is 2. In the denominator, my x of 6 minus this x of 2. 5 minus 2 is 3, and then 6 minus 2 is 4, so I have 3 over 4. Are those two slopes the same? Absolutely. So far, so good. Now, just because these two match doesn't mean I'm done in the question, because the other sides had to match as well. So let's move on to finding the slope going from A to D on the left-hand side of the picture. As I filled in my formula, I went from top to bottom with my numbers. So the y's that I did was 4 minus 2, and then the x was 1 minus 2. 4 minus 2 is 2. 1 minus 2 is negative 1. So 2 divided by negative 1 is just negative 2. So let's check over here. Going from B to C, is that slope also negative 2? So let's see. Going from B to C, again, I went top to bottom as I filled in my points. I have y 7 minus this y 5 over my x of 5 minus my x of 6. 7 minus 5 is 2. 5 minus 6 is negative 1, and 2 divided by negative 1 is negative 2. Did those two slopes match? Again, yes, they do. So I just saw The top and the bottom had parallel pieces. The left and the right had parallel pieces. Is that what I need for a parallelogram? Yes. So I would say that both pairs of my opposite sides are parallel. They each had the same slope from the top and bottom, as well as the left and the right. Therefore, I can say yes, that my shape ABCD is a parallelogram. Tomorrow we have one last section to go through from questions 29 down through 35, so we're almost there, so hang in with me. You guys are doing a great job. So let me know again if you have questions on what we've done so far this week so I can help you as you're preparing for our test next week.